Hello, my name is Kushal Modh from Group 319 and my topic is the chirality of biological molecules. The chirality of biological molecules. The overwhelming majority of complex molecules contain three more than or equal to 3 atoms have neither plane or nor a center symmetry. In दोनों the word chiral means is the Greek word that means hand, just like left hand and right hand. Chirality substance exists in two forms. Chirality substance exists in two forms. First is, as always, left-handed, and second is right-handed. These two configurations cannot be superimposed by rotation of system as a whole in space. They are related to each other as the same way as left hand related to right hand. The chirality is often encountered in world of molecules. It's also determined by so-called asymmetric carbon atom. It's also determined by asymmetric carbon atoms. Chiral carbon are also, let's call chiral carbon. Chiral carbon are also designed with an asterisk. Its saturated organic compound, the four organic compounds, first four valence bonds of carbon, which are arranged at tetrahedral angle relative to one to another, like this. This make a surface, and this is the tetrahedral structure. This is the tetrahedral structure. The properties of chirality is shows mirror effect, but all of 20 amino acid do not show. The exception is glycine. Expecting the glycine, all 90 shows mirror image or mirror image antipodes, or we can say enantiomers. Let's explain with alanine. Alanine have mirror image like carbon, ammonia. Here is H. Here is again, and this COO minus. This and another structure is like this. COO minus, just like a mirror image. This is D and this is L. This is called L amino acid and this is called D amino acid. L is left-handed and this is we call right-handed. The property is the property of handedness, chirality, is exhibited by proteins, carbohydrates, nucleic acids, and also by a number of low molecular weight compounds in a cell. By the way, the carbohydrates in DNA and RNA are always present in deconfiguration. Then the resolution of racemic mixture. The racemic mixture is what? First of all, racemic mixture. Racemic mixture is what? The two symmetric molecules are synthesized in laboratory with 50-50 mixture called racemic mixture. The resolution of racemic mixture with the separation of fluorescent antipodes in vitro, the method also known as asymmetric synthesis. The method asymmetric synthesis is accomplished with aid of chiral substance of biological organ. Usually they are like alkaloids. A compound L is made to react with a racemic mixture DL. Just DL plus a compound L dash is equal to DL dash plus LL dash. Then we know separation of racemic. The separation of racemic mixture into two constituent. It is necessary to make use an asymmetric substance or living organism capable of discriminating between the laboratory and delaboratory forms. To divide into 2L and D, we have to use an asymmetric substance or living organism. These two help to discriminating L and D forms, and this mirror image is discovered by Pasteur in 1848. The chirality exists in living things both at the molecular level and also at higher levels of organization. By the way, the chirality in nature may be molecular or crystalline An example like this is quartz. Quartz is built up of symmetric molecules. Of silicon oxide, but it crystallizes in L. L means laboratory, and D means dextrorotary forms, which possess opposite activities. Optical activities. There is a calculation we can illustrate by a model calculation. Let's calculate. The x1 is equal to ax1 minus bx1, x2 is equal to ax2 minus bx2. Here is A and B are the rate constants of polymerization and degradation. Here are A and B. A and B are rate of polymerization and degradation, where the x1 and x2 is the number of molecule of polymer. X1 and x2, these are the number of molecules of a polymer. This is the formula with which we can calculate all these processes. Thank you.